Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. In this video, we are going to be talking about empirical probability, all right? So if you watched the last video, if you've been keeping up with the order of the videos, the last video we watched, I talked about probability, and I gave you one definition for probability, but this is another way it can be written as a measure of the likelihood of a random phenomenon or chance behavior occurring. So basically, probability is just measuring what are the chances of something happening, all right? Some particular thing happening that we're interested in. We also talked about some probability rules. One of them was that the probability of an event had to be between 0 and 1. We talked about if the probability was 0, then it means it is impossible for that event to occur. And if the probability is 1, that means it is certain that that event is going to occur. Now, one thing, I'm not sure if I mentioned this in the last video, but whenever you are looking at a probability model, you're looking at the probability of all the possible outcomes of a situation. When you add all those probabilities together, it should add up to equal 1. All right, and this is a standard rule for probability. Your probability should add up to equal 1. And then we also talked about theoretical probability. And theoretical probability can also be called classical probability. And one of the things we did was talk about how do you calculate the theoretical probability. And it is calculated by taking the number of the event divided by the total number of the sample space. And that's all your possible outcomes. Now, one thing about theoretical probability is that it requires equally likely outcomes, which is when each simple event has the same probability of occurring. Another thing about theoretical probability is no experiment of any kind has to be conducted. You're just using different principles, such as counting principles, to determine what the probability is. Now, I said all of that because we're going to be jumping from theoretical probability to a different type of probability in this video, and that is empirical probability. Empirical probability is calculating the probability of an event after an experiment has been conducted, all right? So an experiment is being conducted, and now we want to calculate the probability of a certain event. So in empirical probability, your probability of an event is basically, or it's an approximate of the relative frequency of E. All right, and remember we talked about frequency before. It is where you take the number that the number of times that thing occurs divided by the total number. So when we calculate the empirical probability, it's going to be the frequency of E divided by the number of trials of the experiment. All right. So just a quick example, suppose you toss a coin 100 times and you get head 65 times and you get tail 35 times. You get tails 35 times. Based on these results, what is the probability that the next flip will result in a tails? All right. So this is empirical probability that we want to calculate because it is based on an experiment. Now remember we calculated in the previous video the theoretical probability of getting a head when a coin is flipped. But what we want to do now is we want to calculate the empirical probability, meaning based on these results. So that lets me know it's empirical probability. So recall in the last slide that the empirical probability is equal to the frequency of that event divided by the total number of times that that experiment was conducted. So we want to know what's the probability that the next flip would be a head. So the probability of it was tails. We want to know the probability of tails. It's going to be the number of tails, which is 35, divided by the total number of times the experiment was conducted, which is 100. And if you take 35 and divide it by 100, that is going to be 0.35. So the probability is 0.35. What does this mean? This means that out of 100 flips, because that's 3,500, this means that out of 100 flips, 35 of them will be tails. That's what we're estimating. So it's a 0.35 chance that the next flip will be a tails based on these results. Another way you may see your probability is as a percentage. 0.35 as a percentage is 35%. So even though your probability has to be between 0 and 1, if you see it expressed as a percentage, then what you'll need to do is take this percentage and convert it back to a decimal in order for it to be reported as a probability. Okay? if it was as a percentage, we would say there's a 35% chance that the next flip will be a tails. Alrighty, and the next example I have is the data in the table below represent the results of a survey in which 200 people were asked their means of travel to work. We want to use the survey data to build a probability model for means of travel to work. We want to estimate the probability that randomly select the individual carpools to work and interpret that result. And then we want to answer, would it be unusual to randomly select the individual who walks to work, all right? And so this is my table over here, and these are the results from the survey. 153 people say they drive alone, 22 said they carpool, 10 use public transportation, 5 said they walk, 3 said some other means, maybe somebody picks them up or something. I don't know what the other means could be. And 7 say they work at home. Alrighty. So what we want to do is we want to create, first for part A, we want to create a probability model for the means of travel. So we want to calculate the probability for each of these categories. And in order to calculate the probability, the first thing we need to know is the total number of the frequency. The total number of the frequency, if you add them together, is 200. And again, you don't really have to add them together. I mean, you could do it to check, but it told us in the problem that 200 people were surveyed. So that would be the total number of the frequency. And the reason we need that is because we have to use that in the calculation of the probability. So now when I want to calculate the probability of driving alone, it would be the 153, which is the number that said they drive alone, divided by 200. And if you divide that out, you get 0.765. And we would do the same thing for carpool. 22 divided by 200. You divide that out, you'll get 0.11. 10 divided by 200. Divide that out, you get 0.05. 5 divided by 200. Divide that out, you get 0.025. 3 divided by 200, you get 0.015. And 7 divided by 200 is equal to 0.035. All right. And so that will be the probability for each category. You would just take the frequency and divide it by the total frequency. And then if you add up all of these, the 0.06, the 0.765, the 0.11, 0.05, 0.025, 0.015, 0.035, you get 1. And that's what you should get. The total of all of your probabilities for this one model should be 1. All right, let me know if you have any questions, but that's how you would calculate the empirical probability for each. Now let's go and answer the next question. All right, so I typed all that in a table, and the next part was this was to estimate the probability that a randomly selected individual carpools to work. All right, so the probability of carpooling to work is 0.11. So we would say the probability that a randomly selected person carpools to work is 0.11. What does that mean? That's 11 hundredths. So that means out of 100 people asked, we can expect 11 of them to carpool to work. Or if you convert it to a percentage, move the decimal to the left, to the right 2 times, and that's 11%. You could say there's 11% chance that the next individual selected will carpool to work. But the probability is 0.11 or 11 hundredths. And then the next question is, I'm going the wrong way. Would it be unusual to randomly select the individual who walks to work? So the probability of someone walking to work is 0.035. And remember, it's unusual when the probability is really close to 0. And this probability is really close to 0. So we will say, yes, it is unusual that a randomly selected individual will walk to work, because this probability is really close to 0.035. All right, so let me know if you have any questions about that problem and how we answered those. You can put your questions in the comments, or you can email me directly. So taking a look at the two different types of probabilities we talked about, the empirical probability is an approximate empirical probability of an event. So it's an approximate, and it is conducted by doing a probability experiment. And then theoretical probability does not require that a probability experiment actually be performed. It utilizes counting techniques, and it requires equally likely outcomes, okay? So this is basically the differences between the empirical and theoretical. Empirical uses an experiment, theoretical doesn't. And theoretical, it's like saying in theory. In theory, this is what's supposed to happen. So you think about it, you think about all your possible outcomes, you think about all the different possible ways something can occur, and then you divide those two. Now, there is a rule called the law of large numbers that says if you do an experiment so many times that your empirical probability will eventually get close to your classical or theoretical probability. So remember, theoretical probability is the same as classical. So it says as the number of repetitions of a probability experiment increases, the proportion with a certain outcome is observed gets closer to the probability of the outcome. So that's just saying your empirical probability will eventually get close to your theoretical probability if you do that experiment enough times. So for example, when we did this example earlier, let me see, the 35, the coin being tossed 100 times and it being tails 35 times. Remember, the empirical probability here was 0.35. That was our empirical probability. I'm going to just put E here. And then our theoretical probability is 0.5. That's you can get tails once out of 2 times. So that's your theoretical probability right here. So I'm going to put T here. So my empirical probability is 35. My theoretical probability is 0.5, 0.35 and 0.5. Now, those are totally different. This is like saying there's a 35% chance. This is a 50% chance. But what the law of large numbers says is that if I continue to do this experiment more times than 100, then this number will eventually get close to this number. That's what the law of large numbers says. All right. So let me know if you have any questions about any of that. I think that is all I have in this video. Let me just double check. I think the law of large numbers was the last thing. So if you have any questions, feel free to put them in the comments. Don't hesitate to email me and let me know. Thank you for watching, and I will see you in the next video.